Hello, everyone, and thank you for subscribing to this second webinar on sensory data analysis. Today, we'll be talking about how to relate preference to sensations. There has been a first webinar on sensory data analysis. It took place maybe 2 days ago. My name is Jean-Paul Maalouf. I'm a statistical consultant at Excelstat, which is the statistical software I will be using today to illustrate this webinar. So many of you already use it, and for those of you who haven't heard of it or haven't used it yet, this is a good opportunity to discover it. If you have any question all along the session, don't hesitate to submit it in the chatting pop-up window, and I will try to answer as many questions as I can at the end. So I will try to be as intuitive as I can in my speech, but unfortunately, we won't be able to go very deep into the details of how the statistical techniques we'll be seeing today work, because they are very complex and rich. Unfortunately, just in 1 hour, it's impossible to see everything about them, but you will have an overview at least. So here's an outline of the webinar today. I'll first start with a few words on Excelstat. I'll tell you who we are. Then I'll do a small reminder about what we've seen in the last webinar. Then I will show you one way of mapping preference data without reference to the sensory attributes using one technique called internal preference mapping. After that, we'll see 3 different methods which allow relating the preference to sensory attributes. And one of the main differences between these 3 methods, which are external preference mapping, penalty analysis, and CATA data analysis, is the way the sensory attributes are measured. So on what scale we will be measuring sensory attributes. So with preference mapping, external preference mapping, we'll be measuring attributes on quantitative or ordinal scales. In penalty analysis, we'll be measuring attributes on just about right scale. And in CATA data analysis, we'll be measuring attributes on a binary scale, so presence or absence of the attributes. So these are the 4 main features we'll be seeing today. So internal preference mapping, external preference mapping, penalty analysis, and CATA data analysis. Here are a few words on Excelstat. Excelstat is a statistical software that works as an add-on to Excel on PC and on Mac. It's also available for Excel 365 and Google Sheets, so it's available for use in the cloud. In a few numbers, Excelstat has more than 220 statistical features. It has more than 25 employees working at your service, more than 150 users worldwide, 300K monthly visits on the website. It's available in 7 languages and has offices in 3 time zones, so America, Europe, and Japan. There are 10K monthly downloads of the software. Excelstat is developed by the Addinsoft company, and Addinsoft is hosted by a private lab called the Data Factory, which is based in Bordeaux in France. So it hosts 4 other expert companies around data. And there are 45 people working at this lab. And this lab organizes more than 25 workshops, events, and training around data every year. So it's a very active lab in Bordeaux around data. Excelstat is available in the form of 8 different solutions to meet your specific needs. So there are generalist solutions such as Basic, Basic Plus, and Premium. Basic holds all the mainstream and standard statistical features such as ANOVA or regression or logistic regression or PCA or clustering methods. Basic Plus will add machine learning features to Basic. Premium contains the complete 220 Excelstat features. And between Basic Plus and Premium, you have intermediate solutions which are more oriented toward specific fields. For instance, we have sensory, which is really made for sensometrics. And the 4 features we'll be seeing today are part of the sensory solution and are also part of the premium solution, which includes all of the Excelstat features. Okay. There are more than 220 tutorials associated to downloadable data sets. at the help.exerstat.com website. So each feature has its own tutorial available online, a tutorial that will guide you through the configuration of the dialog box and the interpretation of the results, and a few words on how the feature works. Okay, so you have many interesting learning resources. To access this page, you simply need to click on your PDF on this page here. There's also a specific ExcelStat YouTube channel called Stat Cafe, in which you will find different short videos presenting several features with intuitive explanations and illustration using ExcelStat. You also have webinar recordings available freely on the website, so you can access them right here. So we already recorded and uploaded 7 webinars. 6 of them are an introduction to statistical methods, so to how to describe data, how to explore and cluster data. So statistical testing, statistical modeling, and ANOVA, and supervised machine learning and prediction. So all of these webinars are available online. You can watch them back online. So what have we seen in the last webinar? We started talking about sensory data analysis. Sensory data analysis is the science that uses statistics and design of experiments to evaluate human senses. Human senses, which are touch and hearing and smell and taste and vision. That's it. So the purpose of this science is to optimize consumer goods. Here are a few definitions of things we'll be talking about today. What is a product? A product is an object which is characterized by sensory or affective properties. What is a panelist or a judge or an assessor? It's a person evaluating products. A panel is a group of panelists, and panelists can be experts or consumers recruited on the market. A sensory attribute is a sensory descriptor of a set of products. Example, acid or salty or crunchy for food products, vibrant for car products, and so on. Then affective testing is measuring the degree of acceptance or liking or satisfaction or security or any other emotion triggered by a product. So there are 2 distinct blocks of variables we'll be investigating today: sensory attributes, or how the products are perceived by human beings, and the emotions that are triggered by these products. And today we're going to relate both blocks of variables. Okay. So last time we've seen several types of sensory experiments. One of them we stressed a lot on it. It was difference experiments. The purpose of this kind of experiments is to evaluate distances among products without getting into the details of sensory characterization, without measuring each sensory attribute apart. So among these experiments, we used experiments that allowed us to answer this kind of questions. So does changing the recipe of a product induce a difference in its general perception? In this case, we used discrimination tests such as the triangle test and the 2AFC test that we've seen together 2 days ago. Then we ask other questions. For instance, is it possible to map products according to their global differences? So we've seen projective mapping and free sorting experiments from which we extracted data and which allowed us to map the distances among the products by using special statistical techniques such as the status technique. We've seen another mainstream type of experiment, the descriptive experiments, where judges evaluate products over several attributes and sometimes over several sessions. So technically, this kind of experiment is a bit more complicated technically to implement than difference experiments, but you get a more thorough description of the products from the sensometric point of view. So examples, here are some questions we can answer. Which attributes characterize this product compared to the others? Which attributes are well discriminated by judges? In this case, you can use sensory product characterization to answer this kind of questions. Otherwise, there are other questions which can be answered, such as how to measure the quality of a panel. lot of this kind of descriptive experiments. So we've seen last time the sensory product characterization as well. So what we'll be seeing today corresponds mainly or is focused on another family of sensory experiments, which is affective testing. I already told you this is measuring the degree of acceptance or satisfaction or liking or any other emotion triggered by a product. And these data have different formats, so such as liking score that goes from 1 to 9, for instance, or from 0 to 30. It could be also expressed in the form of a choice of a preferred product in a set of products. Okay. This is an example data set that we can have in this case. For instance, we asked respondents on a 0 to 30 scale, how much do you like each of these 10 crisp brands? Okay, so you get this kind of data set. In rows, you have the products, in this case, 10 crisp brands, and each column corresponds to a consumer. So we see that consumer number 3 rated crisp number 2 with 27. So consumer number 3 pretty much likes crisp number 2 and crisp number 7 and crisp number 10, but doesn't like crisp number 4 and number 5. Okay. We'll be using techniques to dive into this complex data set. Among the techniques that we'll use, we'll talk about internal preference mapping. So internal preference mapping, which help answering questions such as, do consumers who like product A tend to also like product B, or to like a little bit less product C? We'll see that internal preference mapping is based on principal component analysis. Okay. Then we will see that it is possible to combine sensory descriptive experiments and affective testing. So combine affective data to sensory data. The purpose would be to optimize the product sensory attributes to maximize effective variables. In this case, we'll be talking about external preference mapping, CATA data analysis, penalty analysis. There are others, but today we'll be focusing on these 3, and I will be mentioning also internal preference mapping. So these are the 4 techniques we'll be seeing today. Let me start with internal preference mapping. Its purpose is to map affective data using scores such as the scores we've just seen. So internal preference mapping maps products in the consumer preference space. Among the questions we'll be able to answer, which products are similar or different in terms of preference? How is our own product positioned with respect to competitive products in terms of preference, or is not in terms of sensory attributes? What is the nearest competitive product to a given product? And is it possible to segment the market into groups of consumers having similar preference profiles? And so on. So we'll be using this data to illustrate things. So how can we dive easily into this data set? It's not really obvious. So how can we, for instance, measure all the relationships in preference among the consumers? We could try to draw scatter plots for pairs of consumers, but that would be a bit hard because you will have hundreds of scatter plots to draw to see all the interrelationships between consumers. We'll be using instead specific methods that allow summarizing the information from big data sets into smaller data sets. And among these techniques, there is PCA. And guess what? Internal preference mapping is based on PCA, or principal component analysis. So internal preference mapping simply maps consumer preferences of several products in a principal component analysis. And for those of you who are familiar with principal component analysis, products will be considered as observations and consumers as variables. Internal preference mapping adds 2 features to standard PCA, so the possibility to remove poorly represented consumers on the first dimensions. You will understand what a dimension is later on. The possibility to project all the remaining consumers on the correlation circle. This also I will show you what this corresponds to. Anyway, let me tell you very quickly how a PCA works in a very conceptual way. So you have one initial data set. Here I've only shown the first 4 columns. with the corresponding rows. Okay. In this initial data set, there is information hidden everywhere, but it's homogeneously spread all around the data set. I have no reason to think there's more information in this area than in this area. Okay. So my goal is to have a vision of a maximum amount of information. PCA will build an artificial data set in which the information is redistributed in a way to concentrate most of it in a few dimensions or in a few columns. See here, I have another data set with also the same rows. So each row corresponds to one of the products. But the numbers here are artificial. Don't try to understand what they refer to, because they don't really have a direct interpretation. They are linear combinations of these numbers. The most important thing you should know in this case is that the first dimensions of the PCA capture the biggest amount of information from the initial data set. So now if I draw a scatter plot out of F1 and F2, I will have a vision of a big amount of information from the initial data set, and I will be able to have a nice interpretation of the interrelationships in preference. If you want to have more information to go deeper into PCA, I would suggest watching the webinar on clustering and exploring data available on our website. This is how a PCA looks like. Okay, and this is actually an internal preference mapping. Okay, so F1, the horizontal axis, is the first dimension of the PCA, or the first column of the PCA, the one that holds the maximum amount of information, and F2 is the vertical axis. Together, F1 and F2 summarize 43% of the information from the initial data set. So there's still some amount of information which is not captured by F1 and F2. Maybe it would be nice to explore also F3 and F4 in this case to have some more information displayed. But now let us stick to this chart, to this map here. Okay, so first of all, check the amount of information represented on the map. If it's too low, maybe more dimensions should be explored. Let us stick to this one. The red points are the consumers. So each red point corresponds to one consumer. And the blue points are the products. Okay. Now, how can you interpret this? Here are some interpretation hints for those of you who are not really familiar with PCA. Here are some hints, but I would strongly advise you to, if you're not familiar with PCA, to do some research on PCA or to request maybe some training from Exerstat or some consultancy. So here are investigation hints. Investigate each dimension apart. So try to interpret each dimension apart, F1, then F2. And very important, avoid interpreting everything which is around 0, 0 coordinates. So all of the objects which are close to the origin here, avoid interpreting them in the corresponding map. So here we shouldn't interpret anything related to crisp number 7. So I will start by interpreting F1 right here, and will interpret each side of the axis. I will start with the right side here. So consumers to the right of F1 are close to crisp number 8 and maybe a little bit number 5. They have positive coordinates on this axis. So we may say that they prefer crisps 8 and 5, and to a lesser extent, maybe 10 and 1. But they have lower liking scores for crisps 3 and 4, which are on the opposite side of the axis. Okay, so they like the crisps which are close to them along the axis, and they have lower liking scores for brands which are on the other side. And we noticed that there are many consumers who have this profile. So maybe crisp number 8 is quite popular on the market. It's quite appreciated, at least on the market. On the other hand, we can have the opposite reasoning. Consumers on the left of F1, if there were any, now we don't see any consumer, but imagine we had like a few. This consumer would prefer crisps number 3 and 4 and have lower liking scores for crisps number 5 and 8. So it's the opposite reasoning. And we see that crisps number 3 and 4 have lower liking scores in general because we don't have anyone on this side of the PCA. Then we can interpret also, of course, the vertical axis, or F2. So consumers at the top of F2 have higher liking scores for crisps 2 and 6, okay, and have lower liking scores for crisp 9, which is at the bottom of F2 on the other side. And also we can have the opposite reasoning. At the bottom of F2, we have consumers who have higher liking scores for crisp 9 and lower liking scores for crisps 2 and 6. So we are really investigating how preference profiling relates to products. Now let me show you how to implement this in ExcelStat. So this is the data set I will be using, which is stored in Excel. And as you can see, ExcelStat appears in the form of an additional tab in Excel. You have several menus that you can use. These menus are part of ExcelStat Basic. They include features for preparing data, feature for data description, for visualizing data, see box plot, histograms, and scatter plots. Data analysis, if you want to run a classic PCA, you can run it from ExcelStat Basic. You can also run clustering analysis from here. You have features for data modeling, so all of these. And then Basic Plus adds machine learning features for prediction. You have statistical tests as well, which are part of the most basic solution as well. And at last, in this menu, you have advanced features, which are part of field-specific solutions or the premium solution. We'll be focusing on sensory data analysis, which is here, and I will select internal preference mapping. So I have a dialog box that appears. This is a typical ExcelStat dialog box, I'll reset it. A dialog box which is made out of several tabs. And within each tab, I can select data and I can configure the option I like. So in the General tab, I will select the data I want to build my internal preference mapping on. So I can select the data in ExcelStat in two different ways. I can either select the field like this, all the data like this, or if the data set starts at the first row and there's nothing under it, I can also select things like this. So by clicking on the letters above the data. So as you can see, I have 99 consumers. Then you can choose different PCA types, but I will choose the classic PCA, the correlation type. Product labels, I select them here. Okay. Then there are many other things we can configure. In the Outputs tab, I will check this option, which is quite interesting, which is filter out assessors. So all of the assessors which will be too close to the origin in the PCA maps, so too close to the 0, 0 coordinate, will be faded out, won't be visible. So this will improve readability and this will prevent us from making abusive interpretations of assessors who are not really well represented on the PCA map. So I would just ask to filter them out. In the Charts tab, I would suggest here to remove the vectors because otherwise the readability will decrease. And I will just add a feature as compared to what we've seen here. This one, move to circle. You will see that it's a very convenient feature or option that allows you to identify some clusters of respondents who have similar profiles of preference. So I click OK. First thing ExcelStat asks me, what dimensions of the PCA do I want to represent in the charts? So with F1 and F2, I am capturing 43% of the information from the initial data set. So I can click OK to investigate at least these two dimensions. If I want also to investigate F3 and F4, I can select them here. So 3 and 4. So F3 and F4 carry 20% of the information. So if I select them, I will have a chart on F3 and F4. So in this way, I will be representing 43 plus 20. This is 63 of the information from the initial data set. So once I'm ready, I click Done. As you can see, there are many outputs, but I will just focus on the most interesting charts. But of course, all of these outputs can be interesting. Unfortunately, we won't have the time to see them all. So I'll go down to the biplot, which we've seen earlier on the presentation. And there we go. We have two, because we selected F1, F2 first, and F3, F4 second. So let me focus on F1, F2. This is exactly the same chart we've seen on my presentation. The only difference is that all of the consumers were projected on a circle. Okay, so this make it easier to identify like clusters of consumers who have some typical preference profile. So imagine here, for instance, we had an isolated cluster of consumers. Here we only have two, like 63 and 71. These two consumers who like CRISP number 6 and who are opposed maybe a little bit to CRISP number 9. So imagine that we had maybe more consumers which are isolated like this. This means that we have a typical preference profile around here. People who like CRISP number 6 and who dislike CRISP number 9. So this way we're able easily to detect clusters. Here maybe there's an interesting cluster around here as well. Okay. And of course you can investigate this chart as well. You see that on F3 and F4, CRISP number 7 gets far away from the origin. So in this map, you can interpret everything related to CRISP number 7. It was not possible to do it in this chart, in this map, because it was too close to the origin. Okay, so now that we've seen how to investigate a preference map or a preference space, let us relate affective data to sensory data. But before doing that, here are different scales at which sensory data may be evaluated. There are 3 scales I will show you. Of course, there are more, but mainly there are 3. First scale, quantitative or ordinal scales. And the way questions can be asked in the survey, in this case, could be like this. To what extent do you perceive the following attributes in this yogurt? We have 3 attributes, sweet, acid, and bitter, and each attribute is linked to a 7-point scale that goes from not at all to very much. So if I take sweet, for instance, and the respondent checks 1, this means that the yogurt is not sweet at all. If the respondent checks 6 or 7, this means that the yogurt is very sweet. So this is a very basic way to evaluate sensory attributes, which is called a 7-point Likert scale. Of course, there are other versions of Likert scales, like 5 points or 9 points or 11 points. External preference mapping helps relating quantitative or ordinal sensory data to preference, and often data are averaged across judges to obtain one value per attribute and product, as you will see in a typical data set that will be introduced in external preference mapping. Now let me tell you about 2 other scales that are commonly used in sensory data analysis. The just about right scale, which imply this kind of questions. We'll try to see the difference in the kind of question with the previous one. Please indicate your opinion about the following attributes of the yogurt. There we go. We still have the 3 attributes, so sweet, acid, and bitter, but this time the scale changes a little bit. In this case, look at the tags of the different answers. It goes from much too little to much too much. And in the middle, you have something called just about right. In this kind of scales, the middle point, so point number 3 here in the scale, has the highest desirability. So in a way, we're already integrating an idea of affection or of affective testing in the scale. So this scale can also be 3-point or 7-point or 9-point. Here I chose a 5-point scale. So low scores means that the attribute is much too little, and high score it's much too much. So it's negative opinion on the 2 extremes, and the most positive opinion is in the middle. Penalty analysis helps relating jar sensory data to preference. Third scale, binary scale or CATA scale, check, order, apply. Please check all the words that best describe this yogurt. We still have the same attributes, so sweet, acid, and bitter. So the respondents simply need to check the presence or the absence of the attribute in the product. And CATA data analysis helps relating binary sensory data to preference. So I will investigate each of these three methods. I will start with external preference mapping, which models product preferences according to sensory evaluations or even chemical composition. So you're not necessarily obliged to model preference according to sensory attributes. You can also model preference according to other characteristics of your product. This can be chemical compositions, for instance, or more economical variables. So it helps answering the following questions. So why are certain products preferred? Is there any sensory attributes behind driving preference? How can I reposition a product so that it's, again, more preferred by its core target? And what new products might it be relevant to create? And usually, preference data and external preference mapping is collected from real consumers who are more representative of the market. And sensory data is collected from expert panel evaluations, so sensory descriptive experiments. So the preference data we'll be using in this case will be exactly the same that we use for internal preference mapping. So those 99 consumers who rated their preference over the 10 crisps. Here's a teaser or an easy introduction to external preference mapping. So just like for preference data, it's possible to build a PCA out of sensory data. Here's a sensory data set, which is built also on the same products that we've seen earlier. Once again, we have one product per row in this data, but instead of having consumer preferences in columns, we have sensory evaluations: hardness, stickiness, crispy, melting, earthy, stuffiness, and so on. We have products in rows and sensory attributes. These are sensory ratings, which are quantitative, which could be evaluation scores averaged over several expert assessors. The most important thing is to have one data set with reference to the products in rows, and another data set with sensory attributes or chemical composition, but still with exactly the same products in rows. Let us focus on this sentence here. It's possible to build a PCA out of sensory data. We'll be able to summarize the information from this data set in a few dimensions. Here's how a PCA from this data looks like. So you have a representation of both the products and sensory attributes on the same map, a map that represents 70% almost of the information from this data set. What can we say out of this PCA? Let us focus first on crisp number 8, for instance. You see this crisp is in the direction of hardness, artificial, and saltiness, and opposite direction of earthy. So crisp 8 has high saltiness, artificial, and hardness score, but low earthy scores. On the other hand, you have crisp 3 and 4 that have the opposite profile. They have high earthy scores and low saltiness, artificial, and hardness scores. Crisps 2 and 6 are similar. They are melting and stuffy and sweet, but they are not sticky and not crispy and not overcooked. So there are many other things that can be said. Anyway, what external preference mapping does is that it allows visualizing regions of high and low preference in the sensory PCA. So we'll just take this PCA and visualize where the preference lies. And this is how things look like. So before checking these colors in the background, can you recognize this sensory PCA or this PCA built out of sensory attributes? It's exactly the same thing we've seen here, but without the fancy colors in the background. Still have crisp number 8, which is here, 3 and 4, which are here. We only added these colors in the background, which simply represent preference. And warm colors represent areas of high preference. Cold colors represent areas of low preference. We still find out that crisp number 8, here again, is linked to a high preference, as we've seen in internal preference mapping. And in addition here, we can say also that perhaps saltiness and artificial and hardness attributes are the attributes which drive preference in this region. And earthy is the attribute that has a negative impact maybe on preference. So there are many things that can be said out of this map. Imagine, for instance, you want to create a brand that drives a lot of preference and it's very competitive to this brand, Crest number 8. You should be trying to develop something around here. So a brand which has high saltiness, artificial taste and hardness, and low earthy notes. But maybe you can also try to find out other regions in this map that could be interesting. Look, for instance, here, there is a lack of products around here. So this is thickness and crispy. Sorry, the words are overlapping. So this is crispy and thick. So maybe there's a good opportunity to develop something around here because you don't have any competitor and you have a fair preference around here. So there are many things that could be said out of this map. I won't be spending too much time on it, but you get the point. Now, for those of you who are familiar with statistical techniques and regression, this is just, let me tell you about the technical way external preference mapping works. Usually the preference of each consumer is modeled according to the first dimensions of a PCA run on sensory attributes. So there are 4 available models in external preference mapping. The simplest one is this one, the vector model. So PCA F1 and PCA F2 are simply the first 2 PCA dimensions of my sensory space. And this line corresponds to one consumer, okay? And it means that preference increases linearly in the sensory space. So in the sensory space, the preference of this consumer increases in this direction. So imagine, I don't know, there's an attribute which goes in this direction. For instance, the crispy attribute. This means that this consumer likes crisps. There are other models which I won't be developing, circular, elliptic, and quadratic, that are available, but I won't be illustrating them. But you just need to know that these models allow defining or pinpointing or locating maximums or minimums of preference in the sensory space. So let me build a preference mapping or an external preference mapping in ExcelStat. I'll be using 2 different data sets. So the preference data set, which is right here, which I will relate to the sensory data set, which is right here. So I will go back to sensory data analysis preference mapping, which is external preference mapping. So the first feature in this menu. The preference data, I simply selected right here. I'll do it quickly. The configuration, so the X data or the sensory data, it could be also chemical composition, depending on what you're investigating. I selected right here. Object labels are the crisps. In the options, you can choose the model you want to investigate, so either vector, circular, elliptical, or quadratic. I would just stick to the vector model for this time. And there are many things you can configure in the outputs and in the charts. And if you click OK, I won't be doing it now because it takes a little bit of time. I will show you the outcome. It's right here. So once again, you get many results which are interesting, but I will just focus on a few charts. You recognize the sensory space. That's the PCA built out of sensory attributes. Then you have the preference space, which is represented by this chart. See here, you have the sensory space once again, in which the preference of each consumer is projected. So each line corresponds to the preference of one specific consumer. And as you can see here, you have a big concentration of consumers that have preference growing in this direction of crisp number 8. And then you have all the other possibilities or superimpositions. And we find out this very interesting chart, which I already showed you. Then at the end, there's something quite interesting, this chart here. This chart allows you to identify in some way the attributes notes that an ideal product should have to receive quite high preference scores. So here we see that an ideal product should have an artificial taste, should be hard, maybe a bit sticky and crispy, but shouldn't be earthy or greasy or stuffy. Okay, so this is an indication of an ideal product that would have a high preference in the market. Now let us check a different way to define potential improvement directions of products to optimize satisfaction. So this was one first type. Let me check another type. So penalty analysis. Penalty analysis is based on just about right data. It helps adjusting attributes so that become just about right. Similarly to external preference mapping, penalty analysis also relates preference to sensory data. First difference is preference data is usually provided by the same assessors who evaluate the sensory attributes. So in preference mapping, we've seen that we can have different blocks of evaluator of assessors. One block assessing preference, another one assessing sensory attributes. In this case, the same assessors should be evaluating liking scores or satisfaction scores and sensory attributes. The second difference is that sensory data are measured on a just about right scale or jar scale. For instance, not salty enough for just about right or too salty. The middle point in the scale has the highest desirability. And penalty analysis is usually more appropriate for a more precise optimization of products. So I remind you that the just about right scale looks like this. Middle point with the highest desirability. This time we'll be talking about potato crisps once again. So this is how a typical penalty analysis dataset looks like. In rows, you have tested samples. In columns, you have one column for preference data. And watch out, the preference data is measured on a classic scale. So from 1 to 9, with 1 meaning low preference and 9 meaning high preference. So you don't have intermediate desirability such as the jar scale. The attributes are measured on the jar scale. In this case, I'm using a 5-point scale. 3 is the most desirable in this case. So I will set up an analysis in Excel set and show you one of the most interesting outcomes from penalty analysis. So sensory and data analysis once again. Penalty analysis. I will capture liking scores in this field, then just about right data right here. I can also add labels for the 3 jars levels. So for saltiness, sweetness, acidity, and crunchiness. So a low saltiness means not salty enough. A high saltiness means too salty. This is just for convenience in labeling. So just select this like this. I need to tell Excelstat what scale I'm using. So from 1 to 3 or 1 to 7, 1 to 9. There are many things, once again, that appear in the outcomes. I will just focus on 2 results, but you should know that there are more thorough analysis which are interesting to take out of this feature. But I will comment on 2 charts, just this one and this one. This one is more descriptive. For each attribute, saltiness, sweetness, acidity, and crunchiness, you have the percentage of people who checked just about right, so in green, and who checked the too much or who checked the too little. So for crunchiness, for instance, 51% of people or 51% of samples were checked as just about right in terms of crunchiness. 39% were checked as not crunchy enough and 11% as too crunchy. Then I really like this chart in penalty analysis because it summarizes quite a lot of things. It gives you really an overview of the most interesting results that come out of the analysis. Okay, so as you can see, you have 4 pairs of bars. Each pair corresponds to 1 attribute. Salty attribute, sweet attribute, acidity, and crunchiness. You have different colors. I'll be explaining what colors relate to. And within each attribute, you have 1 bar corresponding to one of the extremes in the jar scale. So not salty enough or too salty, not sweet enough or too sweet. What does the Y variable refer to? This is the mean drop in liking or the penalty under each circumstance. So it's very straightforward. Let me focus on this one. If the product is not salty enough, okay, then you lose 2.2 points of liking. And the red color means that this is significant. So those 2.2 points of liking are significant. There's a statistical test behind. Same thing for too salty. If the product is way too salty, you lose 1.2 points of liking, and this is significant. So the salty attribute is quite delicate in this kind of product. You should really be aware of this attribute while developing a product, making it not too salty or not with a very low saltiness. Then for those two attributes, which are colored in green, this simply means that mean drops are insignificant. So if the product is not sweet enough, you have a drop of 0.9 or 0.8 liking score, but this is insignificant. So these attributes are less important than saltiness or than crunchiness. Look here also you have a red one, which means that if your product is not crunchy enough, you lose 2 points of liking. But if your product is too crunchy, you also lose a lot of liking, but actually the color is gray. What does this mean? This means that not enough assessors found the product too crunchy to allow the software to compute significance. So we cannot really compute the significance in this case. Anyway, if we get back to this chart, notice that only 11% of samples were checked as too crunchy. So we cannot really test significance in this case. So you see you have very precise and quantified evaluations of what extent do your attributes impact your liking scores. So we didn't have this kind of precisions in external preference mapping. Okay, now let us switch to the last feature I'm going to investigate here, the CATA data analysis feature. I remind you that a CATA survey is binary, so we ask the respondents to check all the words that best describe a certain product. And with CATA surveys, assessors only check the presence or absence of attributes in the products. The convenience of the method makes it possible to survey high numbers of untrained consumers, representative of the real market, which is a bit more complicated when it comes to penalty analysis or to external preference mapping. If the only task to do is to check the presence or absence of attributes, you don't really need a deep training. So you can survey high numbers of real consumers from the market. Here are a few things CATA can do for you. You can compare products in terms of presence or absence of sensory attributes. You can compute liking penalties, just like we did in penalty analysis, if an attribute is present or absent. And you can also incorporate the characteristics of a virtual ideal product. We won't be doing this today, but you should know that it's possible. This is a typical CATA data analysis data set. You see you have consumers in rows, and each consumer is repeated as many times as there are products. Here we're comparing apple varieties. Okay, so the first consumer is repeated 5 times because there are 5 apples, 5 varieties. Second consumer is repeated 5 times as well, and so on. You have a liking score, which is a 9-point Likert scale in this case, and the attributes, which are measured on a binary scale. So 1 means attribute is present, 0 means it is absent. So how do we set up a CATA data analysis in ExcelStat? I'll go back to sensory data analysis and CATA. My CATA data is simply the presence absence of attributes. Products are the products. Assessors are checked here. Preference data, if any, can be included here. So you have many options. When you're ready, you click OK. Once again, there are many outputs in CATA data analysis. We won't be able to investigate them all. I'll just focus on 2 interesting results. This one looks a bit scary like this, but it's not that complicated, don't worry. In this case, look, we have the different attributes in rows and the products in columns. What do these numbers refer to? This, for instance, is the percent of respondents who checked firm for product number 106. So we see that products number 106, 257, and 548 have been checked as firm more often than products 366 and 992. So we can say in some way that they are more firm than products 366 and 992. Each product or each number is linked to a letter. What do these letters refer to? For instance, here for the bitter attribute, you see that all of these products share letter A in common. What does this mean? This means that the percentages linked to these products are not significantly different. There's a statistical test behind named the Cochrane's Q test. While two products not sharing any letter in common are significantly different. This is the case of these two products for the tasty attribute. This means that 257 has a significant higher tasty attribute than product number 106. They don't have any letter in common. Here we have A, here we have BC. Another thing to check is this chart, which is also very synthetic. I really like it. You have a mapping of the different attributes. I will split the chart horizontally. Above this horizontal line, we say that mean liking increases when the corresponding attribute is present. So these attributes increase liking in the products when they are present, when tasty, sweet, apple flavor, crispy, firm, and juicy are present. Right under, you have the decreases. This means that mean liking decreases when attribute is present. So these attributes should be avoided in our apples because they generate a drop in mean liking, okay, when they're present. Now, what does the x-axis mean? This is the percent times attributes were checked. So even though in this part of the chart, these attributes generate a drop in mean liking, they weren't checked very often. So they're not quite often present in the different tested products. So the most exciting attributes are these ones, the one in the upper right part of the chart. So attributes in the top right quadrant have an important positive impact on liking. And in the bottom right, they have an important negative impact on liking. Maybe the sour attribute should be avoided. So to sum up, internal preference mapping provides a synthetic view of how products are positioned in the consumer preference space, does not involve sensory characterization of products. External preference mapping allows relating preference to quantitative or to sensory attributes measured on the quantitative scale. Penalty analysis allows optimizing products and is based on attributes measured on a jar scale. And at last, CATA data analysis allows relating preference to sensory attributes measured on a binary scale. And there's something important about CATA, is that its convenience makes it an ideal method to survey untrained consumers. So thank you very much for attending this webinar. Don't hesitate to download the 14-day trial of ExcelStat, and I will answer questions right away. And if you need some more thorough consultancy or training for your specific cases or specific questions, don't hesitate also to send an email to ExcelStat. I will check a few questions now. How can you get the record of this webinar? You will get a link soon. Can sensory attributes be evaluated by consumers as well as preference? Well, in some cases, yeah, there are studies which use consumers as evaluators. But in this case, I would recommend using the CATA scale, which doesn't really need deep training. Thank you very much for attending this webinar. I hope you enjoyed it. Well, enjoy using ExcelStat if you're doing it. Otherwise, enjoy using the 14-day trial. Thank you very much. Bye-bye.